Alright, so we're going to take the derivative of this one. If you look at this one, and some of you will say, I will use quotient rule to take the derivative. But if you look at this one, in the quotient rule, you're going to run into chain rule, and look at the chain rule, look at your denominator is to 1/2. It's really complicated. So instead of using the quotient rule, we're going to apply natural log property. We break it down into smaller terms and then take the derivative one by one, which is going to be easier and less likely to make mistakes. So it seems to be more steps, but actually it's easier for you to take the derivative, right? So for this one, what I would do is I'm going to take natural log of both sides. So natural log of y, so I raise the second term, also the same thing, x minus 2 squared over x squared plus 1 to the 1/2, okay? So now, when I look at this one, natural log of y, again, I have not taken the derivative yet. I'm just rewrite the function, apply the natural log rule that if I make it easy for me. So this would break into a natural log of x minus 2 squared minus natural log of x squared plus 1 to the 1/2, okay? So division turn into subtraction. Again, I'm not taking the derivative yet. I apply the power rule. So natural log of, I move the 2 to the front, so natural log of x minus 2 minus 1/2, natural log of x squared plus 1. Okay? Now, I cannot rewrite this any further, so I'm going to take the derivative on both sides. Okay? So this is the implicit differentiation applied in this situation. Because I'm taking the derivative of y, right? This is natural log of y. So you have two variables in the one problem. So how do you know when it's implicit differentiations? Is when in your equation, in your function, you have two different variables. And you have to take the derivative of both at the same time. So this is derivative of natural log of y, which is 1 over y dy over dx, right? Okay, over here, the 2, 1 over x minus 2 times 1, I'm putting bracket. This is 1/2. 1 over x squared plus 1 times 2x, okay? So I'm missing a parenthesis right here because the 2 is a coefficient. I can just put it in front. Right, so 1 over y dy over dx. Let's see what I can simplify. So this is 2 over x minus 2 minus, this 2 cancel out, so x over x squared plus 1. Now, when I look at this problems, I have the 1y over here, and then we want to find the derivative, which means I want dy over dx by itself, so I need to move the y over. So in order for me to move it over, I multiply the whole thing with y, right? And multiply this by y. Okay, so the y cancel over here. I will have dy over dx is equal to y 2 x minus 2 minus x squared plus 1, okay? But the problem is we cannot leave the two variables in the same function, so I need to replace the y, which is not so difficult. It sounds complicated, but it's not. We go back to our original function. If you look over here, right, we have y is equal to x minus 2 to the second power over square root of x squared plus 1. So instead of y, I'm going to replace in y with the original function, which is x minus 2 squared over square root of x squared plus 1 to x minus 2 x squared plus 1. Okay, and for this one, most of the time they would just ask what you can do is really you can just stop at this point and then you don't have to simplify. If they ask to simplify, then we can simplify, but most of the time they just want you to apply the log, apply log property before take derivative, and they just say, but you don't have to simplify. So we can stop right here, and let's not simplify, because most of the time you probably don't have to. Alright, so this is example 5. Again, how do we know when we need to apply the rule? Is that look at the function. Think about if you're going to take the derivative of that function. Is this going to be easy, or is this going to be a crazy things that you have to get through, right? Look at the function itself. It's complicated. Do you have the rule to take the derivative right away? If not, can you rewrite, can you apply the rule that you already learned? So that's why you spend a lot of time in pre-cal to learn all the logs, e to the x, natural logs, and all of those properties, just so now when we run into complicated problems like this, we can apply those and make it easy on you, right? Again, if you have any questions, please see us, and hopefully that I will see some of you in office hours, so please watch. Thank you for watching the video. If you have questions, let us know. Ms. Conan will post, remember the worksheet that she gave it to you on Friday, not Friday, sorry, on Tuesday, I'm so sorry, on Monday, she will tell you which problems will be homework questions, alright? Again, thank you for watching. Let me know if you have any questions. Enjoy your Thanksgiving break.